oven is our HTMA 6220. That's a high temperature modified atmosphere oven at 600 degrees C max and 220 litres. Modified atmosphere means the chamber is completely sealed, so we can pass an inert gas into the chamber excluding air, and part of that is that the door has quite heavy duty catches and a silicone seal. The heavy duty catches compress the seal to keep the air out. This oven is mounted on a stand, which you can see here. That's an optional extra, and can be made any height really to raise the oven up to a convenient working height as the customer desires. The gas that we're passing through the chamber to modify the atmosphere comes out of an exhaust pipe in here. This is just a heat shield to prevent anybody touching the hot exhaust pipe. So if we look inside the chamber now, we can see the way we make this fully sealed is by welding all the seams, make a sealed box. The thermocouples and the elements, you can see two thermocouples at the back there, come through compression glands which fully seal them. Now in this design of oven, the air circulation is produced by the fan that's at the back there. The fan sucks into those vents and blows air out of two slots on either side of the chamber, so that there's a generally horizontal circulation of air. This oven's fitted with two shelves. In this case it's going to be used for heat treating semiconductor wafers, so the customer is going to put a rack of wafers on each shelf, but those can be configured in many different ways. We'd have more shelf runners and any shelf positions that are required. In this case, this style of oven can achieve can easily achieve 50 parts per million of oxygen when purged through with nitrogen or argon, and if left to run a bit longer, in this case it can get down to approaching 10 parts per million of oxygen. The gas inlet to the oven is here. This is a 10mm compression fitting in this case, but lots of other fitting styles are possible as customer requires. There are internal solenoid valves behind this panel which either turn the gas off or direct the gas to either of these two rotameters. Now these two, the way this normally operates, you have a relatively high flow one, in this case up to 100 litres a minute, used for purging the chamber, so that's when it's initially full of air. You set a high flow to blow the air out, and then when the right oxygen level has been achieved, the solenoid valves will switch over to the process rotameter, so that's a lower flow, just sufficient to maintain the low oxygen level without consuming excess gas. This feature on top of the door here is a switch which detects when the door is open or closed. That's normally used to turn off the heaters and the fan, and in this case the gas as well, when the door's open. And also in the case of this oven, what we've done is used that as a trigger to the controller to start the heat cycle, so that the program can run a continuous loop. The customer just has to open, load, close the door, and the next cycle starts automatically. On the top here, we can see a bit better now the exhaust system. This is where the nitrogen comes out after passing through the chamber. Inside this little box is a non-return valve, which makes sure that air can't diffuse back into the chamber. In some cases, normally actually that's exposed and the nitrogen is just vented into the room. In this case, we fitted it with another compression fitting so that the customer can pipe the nitrogen away into a suitable duct. Another optional extra on these HTMA ovens that we've got in this case, just fitted here, connected to this wire, fitted into the exhaust pipe, is an oxygen monitor. That's capable of detecting the oxygen level in the exhaust independent of temperature. It's of the type similar to used in car exhaust systems, and In this case, this connects to the oven controller, and we can use it to trigger different parts of the program. So the purge gas will come on, we'll wait until the oxygen level has reached the desired threshold, in this case 50 parts per million, and then the heating cycle is triggered. Behind that, here you can see another exhaust pipe. This is a special feature of this oven which has rapid cooling. In this case, because it's a modified atmosphere, the cooling air is not blown through the chamber but round the outside in special ducts fitted between the chamber and the insulation. This has two air blowers in the back which produce about 120 litres per second of air, and that's able to cool the chamber down from 420 to 200 centigrade in about 25 minutes, which is roughly 10 kilowatts of cooling power. So that then matches the heat up rate of the oven. It can cool down roughly the same speed that it can heat up. If it didn't have rapid cooling like that, it would take many hours to cool by the same amount. In order to stop excessive airflow cooling the chamber too much when it's not required, this has an electric damper actuator here which turns a butterfly flap inside the chimney to close it off when the cooling is not required.